Okay, so this is a voltmeter. Oddly enough, it measures voltage. That was a wow. Velocity? No. Okay. So to give you an example, so I've got this hooked up to your basic square battery. And we're reading 6.25 volts. Okay?
But it's a 9-volt battery.
Yeah.
It's partially dead.
Partially different. Okay? So this is an older battery, but it still has some charge to it. Okay? Right? It isn't dead, but we got 6.25 volts. So basically, that's a measure of how high the hill is. Okay? Relatively speaking, that's not bad. Okay? So the point being is that the battery has the capacity to do work. I can use these chihuahuas to do work. I can make them run a light bulb or something like that. Okay, so now I'm going to take this, and here's my setup. So I've got my zinc here, elemental zinc, and I've got a strip of copper over here. So I'm going to pour, oddly enough, zinc nitrate. Put it in there. Pour some copper nitrate in here. Okay, that. And put the pipette inside.
You.
Oh, I promise that was not me.
We watched you yesterday.
Bird can't buy us footage.
Yeah.
I watched you do it. Or no, Adam
I
watched you do it.
promise you.
I promise. How much?
So
If I get video footage of it, can I correct my physics test for free?
No.
You know you're lying.
I might have done that yesterday.
Now you
Okay.
fix it.
Now, so this is a solution of potassium nitrate. So this is just filter paper that I'm going to put in here. So this is going to build the salt bridge. So I'm going to connect this across like this so that it's down in both solutions. Okay? So now I'm going to hook this up over here. With the nitrate.
It's going to explode.
No, it's not going to explode. If it explodes, so many other things are going bad.
Mr. Verkamp,
Right.
how come it's a salt bridge if it's like not salt?
Okay.
It has
Adam lied to me.
I did never say that.
You did. You lied.
Okay. So the voltage on this is 0.87. Okay? No. Won't make any difference. Okay?
It's
Higher concentrations.
Oh, we'll deal with that later. Okay? So right now, these are both 1 molar solutions. So here's what we have. So over here, we have the zinc, we have the copper, right? So what did we say was happening with the copper? What was it doing?
It's being reduced.
So it's taking in electrons, right? So over here, the Cu2 plus is gaining 2 electrons, and it's turning into elemental copper. Cool. So over the period of time, what's going to happen to the mass of that copper?
It's going to increase.
It's going to increase, right? Because as this runs, we're going to increase the mass of that copper. Okay? Now, over here, you got zinc nitrate. So if this is happening over here, where the copper is gaining the electrons, what has to happen over here?
Because of oil.
The zinc has to turn into
Zinc 2 plus.
Bn2 plus and 2 electrons, right? So this is going to be oxidation, and this is going to be reduction. Okay? Now, in terms of terminology, when you have a voltaic cell like this, you have something called the anode, and you have something called the cathode. Okay? So the anode is where oxidation takes place. The cathode is where reduction takes place. Now, there's 2 ways you can remember this depending on how much of a pet lover that you are. Okay? So if you're into animals, you can remember this as an ox and a red cat. Okay? Reduction happens with cathode, red cat. If you're into letters, these 2 start with vowels. These 2 two start with consonants. Okay? So you can remember red cat, anox, vowels, consonants, I don't care. Just remember this. So here's the question. The anode is where oxidation is taking place. So this side over here is your anode. And this side over here is your cathode. Cool. Okay? Anode, cathode. Now, let's track the path of the electrons. Are the electrons moving from the zinc over to the copper, or are they going from the copper over to the zinc?
Zinc to copper.
I agree.
I like that.
Zinc to copper?
Yeah.
Okay? So it's moving from the anode to the cathode. Easy way to remember that, it's like the alphabet. A before C. So it goes A to C. Okay? So the electrons always move from the anode to the cathode. No exceptions. Zero zip. None exceptions. No, that's the way it goes. Okay? Because here's what's happening. Again, from a social norm. The copper ions are over here going, hey, these are chihuahuas. Sends a signal over here to the zinc. These electrons in the zinc, not in the solution, okay? Zinc 2 plus is not giving up its electrons and turning into Zn3 plus, okay? This is not happening. The zinc is giving up its electrons, not the zinc ions. And the copper is not gaining an electron. We're not making Cu1 minus. We're the copper ions. Okay? So the copper ions are taking in the electrons. The zinc is giving up its electrons. Electrons are going around like this. Cool. Now, here's the other part of this story. What's happening to the zinc ion concentration? Going up.
Increases.
So we're increasing the zinc ion concentration. Over here, what's happening to the copper ion concentration? It's going down. Okay? So if I let this run long enough, what do you think is going to happen to the voltage?
It's gonna go down.
It's going to go down. Because what's going to happen is that you're going to have fewer and fewer copper ions over here going, yo, instead of everybody sending out this blast of social media, the number of copper ions that are going to be pulling these is going to go down. Okay? Now, over here, this is going to get crowded. Okay? So you have two things working against you. You have fewer copper ions sending out the text message going, big party, let's go. And then over here, the zinc ions, this is going to get crowded. And the zinc's going to go, this is awkward. Okay? It's crowded. I really don't like people. I don't want to go out. Not cool. So, but as this increases the zinc ion concentration, and you decrease the concentration of the copper ions over here, here's what's going to happen. What's going to happen to the total amount of positive charge in this solution?
Increase.
It's going to increase. So I'm going to increase the positive charges over here. But what's going to happen over here? I'm going to decrease the positive charges over here. Now, Mother Nature is going to flip out. Mother Nature is going to go, this is bad. And I'm going to show you how I know this. Okay? So look at the voltage, 0.7, whatever that is. As soon as I take out that salt bridge, that voltage drops to 0. Okay?
-0.
Well, it isn't quite calibrated. But if I put that salt bridge back in, voltage goes back up.
So are we dissolving that zinc and actually making copper metal?
Yeah.
What's the salt bridge do?
Wait, so
Now,
Yeah.
now, let's talk about the salt
If
bridge.
you
Let's talk about the
left
salt
it
bridge.
like
Let's talk about the salt bridge.
Whoa,
Whoa, back up.
Time out.
Okay. So here's a common misconception about the salt bridge. You go, oh, the electrons are moving through the salt bridge. That's why when you take it out, the reaction stops, because that's where the electrons are moving. Get rid of this idea right now. Get rid of this idea right now. The electrons are not going through the salt bridge. You're going, but clearly it's vital, because if I take the salt bridge out, what happens?
It don't work.
It doesn't work.
It don't go down. What?
Grammar, people, grammar. Now, for those of you that have studied World War II, what was the role of Switzerland?
They were so neutral, bro. They were
Oh, it's neutral.
You let everybody walk all over you.
Okay?
No, they were the bakers.
Nazi gold. They let the Nazis put their
So
gold there.
Switzerland remained neutral. The salt bridge is Switzerland. It maintains electrical neutrality. Okay? You have a solution of potassium nitrate. So how is this existing in the solution?
Ions.
Ions. You have positive ions, and you have negative ions. Now, think this through. So over here, which is the cathode, okay, you're decreasing the amount of positive charge. Mother Nature's going, this is bad. This is bad. We're dropping potassium. We're dropping positive charge. We need to replenish them because we want to remain neutral. So where can Mother Nature get more positive charges? From the salt bridge. So if I'm decreasing positive charges over here, what's going to go over here? K plus.
Dude, it actually matters.
Now, wait for it. This is cathode. Wait for it. Cathode.
Is that Germany?
The potassium goes towards the cathode. What do you call a potassium ion? Cation. Ooh.
Cathode.
Ooh.
Wait, no. I learned that.
What world?
The cations on this side and the anions.
Pretty self-explanatory.
Yeah.
Okay.
Quite simple. It's textbook.
Textbook.
So the cations, oddly enough, go to the cathode side. Now, over here, we're building up too much positive charge. Oh yeah, it's like, people that are like way too positive. Hi, I'm different. Okay? Way too positive. We need to turn that way down. Okay? We need to turn that way down. We need some negativity to balance out the. So, how can we balance out positivity? Oh, so the nitrates.
Anion.
Oh, the anions. So the anions go to the
Normandy Beach.
anode.
It's like the German
It's
army.
basically
D-Day.
Yeah, this is D-Day.
This is
NO3 is a bomb.
Hell, I think I see Saving Private Ryan.
This is Omaha Beach.
That's
Okay. So here's. Okay, I've never had a group run with a World War II analogy like that. But there's a couple of things I want you to remember. The electrons do not move through the salt bridge. So what happened when I took that salt bridge up, Mother Nature goes, we got so far out of whack in terms of neutrality. We had such a big decrease in positive charges over here, and such a big increase in positive charges over here, Mother Nature goes, oh, I can't deal with this anymore. I'm just going to stop. Okay? And she goes, I'm not going to let the chihuahuas move anymore. That's literally what happened. We are too far out of balance. I'm just going to shut everything down. But as soon as I put that salt bridge back in, Mother Nature goes, oh, it's all good. And then Mother Nature let the electrons flow through the outside. So the electrons flow through the voltmeter. So basically what the voltmeter is measuring is the desire for the chihuahuas to move downhill. Okay? So the chihuahuas want to move because copper wants to get reduced. And zinc says, hey, I'm better off without the super chihuahuas anyway, go be free. Got the idea? Okay, back we go.